Welcome back from winter holiday. I hope everyone had an excellent break. I'm sorry I'm not able to be there with you today, but virtual Miss Smith will have to do. We're going to take some notes, so hopefully everyone has received a note packet like the one that's in front of you. If you notice, looking at this first diagram, there are two lines on this graph. One is decreasing and has a negative slope. The other one is increasing with a positive slope. This type of graph is called a system of linear equations. If we break this apart down here, system means it has more than one, and then linear equations. So when we put that together, a system of linear equations is going to mean that there's more than one linear equation. There might be two, there might be three. But notice these are both lines. We will eventually talk about systems of quadratic equations or systems of cubic equations. So what do you think the solution of the system above is? Notice this word is underlined. What is the solution? If you look at that graph and you think about what solution is, normally when we're solving an equation, solution is what value you get for x when you solve for x. Well, in a system, I've got two variables. I've got an x and a y. So the solution to a system of equations, of linear equations, is going to be the x and the y value that they share in common when the input and the output are exactly the same. So graphically, when we look at this graph, the solution to a system of linear equations is the intersection of the two lines. The intersection of the two lines. Moving on to the next page, it starts off by asking the question, well, what if I'm not given a graph? I'm only given two equations. Well, no graph, no sweat. Another way to solve a system of equations is algebraically via the substitution method.